Hello everyone! Welcome to this video where we try to solve the exercises that were posted in the last list video that we watched or created. Now, if you haven't watched that video, I highly encourage you to watch that video because a lot of the concepts that we will be using to answer these exercises were discussed in that video. So, without further ado, let's start now. So for the first exercise, we are to create a function that sorts only the strings in the list of gadgets. If you remember in the last video, I also challenged you to maybe reverse or invert the problem in such a way that maybe you just want the numeric ones to be the one that's sorted. But let's do both right now, though it'll be important to get first the problem proper, which is just the strings. So let's copy this one, this gadgets list that we have here, okay, and create a new cell, and this will create the gadgets variable. Let's call the function sort string, sort strings variable, and it requires a list of items. After you enter this list of items in this function as an argument, then the first thing that we need to do, of course, there was a hint that was given at the end of that video. We're going to traverse this list, and one by one, we are to test if the element is a string, because the requirement only asks us to sort strings. We should isolate just the strings and do not need to worry about the non-string ones. If we're going to isolate those strings, we must have a container. A lot of the particular exercises that we have been doing all starts with creating an empty container. So let's start and create one. So this will be the result container. So empty list, which will contain the filtered items, and then we loop through the list and check if the element is a string. So to do that, the code is for item in list of items. It'll be important that you refer to this list of items or this variable as this one, as this is the argument that we have entered in this function. For item in list of items, if the type of that item is equal to string, then we will append that item here in the result variable that we have created. And finally, because the requirement, we haven't really been told if it's an ascending or descending order, but if it's an ascending order, then by default, if you remember or if you haven't discussed this, the sorted function it's a built-in function that would give you, for example, something like this one. It will automatically sort provided that they are of the same data type according to ascending order. So for example, you have your apple, cherry, and let's say banana. The sorted one would give you the banana one being, of course, placed before the cherry. Similarly, if you have, let's say, for the integer, let's say you have 1, and then you have, let's say, 56 and 2, the sorted function would sort this list according to the ascending order. If we want to make it in reverse order in such a way that it's descending, then we supply the reverse parameters to be true. And you see here that it will now return to you a sorted list in descending order. So say for example, we just need to sort the list in no particular order. It will be assumed that it's in ascending form by default, so we will just return the result. And to try out this list, we want to try this sort strings and enter this gadgets here. And now you can verify for yourself that camera, laptop, mobile, speakers, and television are just strings and that they are sorted according to the ascending order. Of course, as we have discussed, if you want it to be in descending order, you would supply the argument reverse equals true, and it will reverse the order that we have seen earlier. Similarly, if you want to just sort this int type or float, so we will be changing this one to int, or now we're adding another argument, or maybe this one, the bitwise or, okay? Because we have an integer and we have a float, right? So there. We just really need to have the item pass either one of this condition. If this is true and this is false, it will still pass. If this is true and this is false, it will still pass. And the only time this will not pass is if it's both both of these conditions aren't true, and that is if they are a string. So and maybe it's better to change the name to sort numeric and sort numeric, and let's try. So the reason for this is you need to place this first in parentheses so that Python knows that this is one condition and that this is one condition. Okay, there you have it. It's 27, 100, 310, 0.28. And if you want this to be in reverse order, then you just need to supply the argument reverse equals true. Exercise number 2 is actually quite simple. We are to check if the list that is supplied in a given function, or provided as an argument in a function, is sorted. So in this particular problem, we are already told that it needs to be in ascending order. So a lot of what we have used in the first exercise will also be used here. So let's say, for example, maybe let's just use this, for example. All right, so maybe this is our trial list. Okay, and create a function, let's call it is sorted. Okay, and of course it will print true if it is sorted in ascending order and false if it's not. List item. So basically we just need to take that list item, okay, and compare it sorted list. So the list item should be sorted, and it will automatically be already in ascending order. So we just need to return sorted list equals for comparison, or we're saying is it identical to the one provided list item. That's simple. Even without you sorting, the list item that has been provided is already in ascending order, so this one and the one provided will be identical, and this will be true. Otherwise, it will be false. So let's try it. So is sorted and trial list. It's false. However, if, for example, we change this to, let's say, maybe 200, so that now it's sorted, it will be true. And that's simple. So for the last exercise, we are to write a function that takes the sum of the diagonal elements of a 2D array. So I've also hinted that this is something that a data scientist would probably want to write as a function. But let's kind of discuss how to navigate a nested list. This is an example of a nested list because this whole matrix variable is one list, and you have its elements. The first element is a list with 1, 2, 3 as its element. The second list has its elements as 4, 5, 6, and the third list, or the last element, or the last list inside the matrix nested list, is that of 7, 8, 9. Now, let's say, for example, you want to access this one. So, of course, you need first to isolate that first list. So, that would be matrix. And since that is the first element, that would be matrix 0. If you want to access the first element in matrix 0, it's matrix 0, 0. Same in this case, for example, since we are to add the diagonal 1, 5, and 9, so I need to access this second list, and that will be matrix 1. And this is, of course, when you get to that matrix 1, the first index matrix here, 5 is index 1. So you're seeing the pattern now. For example, for the last list, which is index 2, so this is index 2. If you want the last number, that will also be index 2. So we assume that this type of problem, and if you have a diagonal, actually it's not an assumption, if you have a diagonal, or if you're able to calculate a diagonal, you must be a square matrix. So to write a function, and taking that into consideration, let's write a function that we should call sum diagonal, for lack of a better name. And we have here a nested list. Okay. Now, in this case, to sum this, similar to what we have done earlier, we can use a built-in function. In the past exercises, we have used the sorted built-in function. Here, we're going to use the sum. But if we're going to use the sum, there must be a list where the sum function will be applied to. So let's say, for example, here, let's call this diag elements, or those elements that lie in the diagonal of the matrix or the nested list, and let it be an empty list. So this will that lies in the diagonal. Alright, now we now iterate. So for example, for this case, because it's a nested list, recall, if you want to get its length, it will give you the number of lists inside this nested list. So what I will do is for list, or maybe for item, just let's make it for I in range or len of nested list. Okay, right? So we want its count. And as we go through the loop, we append each diagonal element. So take a moment to understand what just happened here. We know that to access this one, it's matrix 0, 0, this one is matrix 1, 1, and this is matrix 2, 2. That means that at whatever index you are already, for example in this case, the diagonal element will also be found on that particular index. So we've seen that earlier, and this is what we've been doing. So we will try, of course, the answer here should be 15, but we can actually try to make it a 4x4 later, maybe just 2x2, and this formula will still work, okay? Because that's how you find the diagonal, or the elements that lie on the diagonal of a matrix. So after that, of course, it's actually quite easy. Just return the sum of the diag elements. And let's try. Sum of the diagonal, and we will use the matrix. And there you have it. Now let's try. Let's say, for example, we make another matrix. For example, here we're writing this matrix, but let's make it a 4 by 4. Let's say this is 8, doesn't matter. So 9, and maybe make this 5. Okay, and since it's a 4 by 4, we want another one, and maybe let's make this 4, 2, and 6. Okay, so now the diagonal, the sum of this diagonal will be 20, right? Because it's the same diagonal and we just added 5. So now this new matrix element should give you 20. Or if you want to try it on a 2 by 2 one, okay, so we just need to remove this and this. So now it should give you 6, all right? So this function will give you 6. And that's it. And that's it for this round of exercises. Hope you found this challenging enough, and of course you were able to leverage what you've learned. There are actually a lot of new concepts that we have just learned just in this video, but hopefully they help you navigate through the complexities of Python programming a little bit easier. And I hope this exercises made you a little bit more confident in using lists as part of your code in the future. So till the next video,